Here we're going to take a look at models for division, and there are three models that we'll go through: equal grouping, sharing or partitioning, and then array and area. So array and area is pretty clear anytime you have a rectangle with a length and a width, or if you have items that are arranged into rows and columns, then you know it's going to be an array problem. However, the ones that are usually confusing are equal grouping and sharing partitioning. So this is probably the tough spot, is how do I decide which one is which? So there are a couple ways you can tell. One is by using the picture and the other is by using the setup equation, because when you first read these problems, they're going to look really similar if they're equal grouping versus if they're a sharing problem. So we can see this first example here. It says you have 14 brownies to put in care packages. If you put 4 brownies in each package, how many whole packages can you make? And then how many brownies are left over? So looking at this one, we could possibly tell by looking at the question that they're asking. So basically, with the equal grouping problems, we won't know how many groups, but we will know how many are in each group. So in this case, we can see that the groups would actually be packages, right? So do we know how many are going in each group? Yes, we do, right? It says here that there are 4 brownies in each package. Do we know the number of groups? No, that's what we're trying to find, is how many whole packages do we need? So that would tell us that it's equal grouping. Versus if you look at the sharing partitioning problem here, it looks very similar at first glance. It says you have 14 quarters you want to give to your 4 friends. If each friend gets the same number of quarters, how many quarters will each friend get and how many quarters are left over? So it sounds very, very similar. But in this one, do I know how many are going in each group? So in this case, each group is a friend, right? And so I don't know how many are going in each group, right? I do know how many groups I have, right? I know I have 4 friends or 4 groups, and they're each going to get the same number of quarters, but I don't know how many they're each going to get. So if I don't know how many go in each group, that makes it a sharing problem. And this is a little easier to see once we look at, like I said, the picture and the setup equation. So to start the picture for both of these, we're just going to draw our objects. So you can see here, I've got 14 brownies that are drawn, right, for the first example. So I would start that the same, whether this were equal grouping or sharing partitioning. And so then what I would try to do, so keep in mind that we don't know the answer. We're trying to use the picture to find the answer, right? So it says here, if you put 4 brownies in each package. So let me start doing that. So you can imagine if I actually had brownies or something like that, or toy brownies, I could start putting them into packages, right? For the drawing, I'm just going to circle, right? So it doesn't matter which ones. I'll just take any 4 and say, okay, that's going to make one group or one package. And so there's one package. Do I have enough to get another package? Yes, I do. So let me get another 4. Do I have enough to get another package? Yes, I do. I can get another 4. And then do I have enough to get another package? I do not, right? So at this point, I only have 2 left, so that's not enough to get another package of brownies. So if you know how to make your groups, right, before you find your answer, so we haven't officially said what our answer is here, right? But if we know how many go in each group and we're actually able to draw those groups, then that would tell me it's an equal grouping problem. And so in this case, I can see that the answer to this, even before I've done the setup equation, the answer is that I can make 3 whole packages. And then it did also ask for the remainder. So in this case, there were 2 that did not get circled or put into groups. So 3 packages with a remainder of 2, but we're going to go ahead and put the remainder, the units on there as well. So if we were just doing, a problem here, we'd just say 3 remainder of 2, but since this is a story problem, we need the units. And notice here that the units on the remainder are different from the units on the answer, on the quotient. So 3 packages with 2, it's not packages, but actually brownies that are left over. So that's another way that you can tell every time you have an equal grouping problem, you should be seeing different units on your quotient and your remainder. So another way you could tell without using the picture is if we did a setup equation, and we could have started with this. You can really do this in any order. So in this problem, we already know that the two different units that are being used are packages and brownies. So when we do a setup equation, even though we may end up using division to solve it, we're always going to set it up as a multiplication setup, right? So I'm going to have some number times some other number equals some total, right? And I've left room here, so I've got blanks for my numbers, but I've left room here for each of the units. And so the one I always like to start with is the second number or the middle number in my equation, because that middle number always has a part to it, meaning that it's going to use both units. In this case, my units were packages and brownies. So that means that that middle number is either going to be packages per brownie or brownies per package, right? It has to be one of those two. Because remember, in our multiplication model, our repeated sums or groups of objects, we say the first number is the number of groups, the second number is the number of objects per group. So you're always going to see both units and the word per between them on that second number. So then I just have to decide what makes more sense, packages per brownie or brownies per package. In this case, it would make more sense that I would know the brownies per package. And so another reason that I always like to start with that second number is because every single time you do this, whatever word comes after the word per is going to be the units on the first number. So this is going to have to be packages. And then whatever comes before the word per is going to go on your answer. So this is going to be brownies, or if you wanted to say total brownies, that's fine as well. So then all that's left now is to fill in the blanks with the numbers that I know. So what numbers do I know? Well, one of the numbers they give me was 4, right? It says if you put 4 brownies in each package, so that would tell me not the total brownies, but brownies per package would be 4. And then the other number they give me here is 14. It says you have 14 brownies. So that would be the total number of brownies. So then that means that the unknown value, what I'm trying to find, and what they asked for here is how many packages can you make? So even though we were able to solve this with a picture, we can look at this multiplication setup and say, well, actually, the equation that we were solving here is the equivalent division equation, because how do you find what you would multiply by 4 to get 14? You would do 14 divided by 4. So technically that's what we did here is 14 divided by 4, and we got an answer of 3 remainder 2. So then let's take a look at our sharing or partitioning problem. So I'm going to go ahead this time and start with the setup equation instead of with the picture, but I'll still do both. So the setup equation here, I know that my 2 units, again, I'm going to do a multiplication setup. My 2 units in this problem are, looks like quarters. And then what else is it talking about? It's talking about giving it to friends, right? So I have quarters and I have friends, which means that this middle number is either going to be quarters per friend or friends per quarter. And I think quarters per friend makes more sense, that I would know how many quarters each friend gets. And again, I like to start with that one because that tells me what the units are going to be elsewhere. So whatever comes after the word per goes on the first number. So this would be friends, and whatever comes before the word per is going to be what it's equal to. So quarters, or if you want to say total quarters, it's fine either way. So what do I know? Well, I know that I have 14 quarters, right? That is not per friend, that's the total, right? 14 quarters to give my 4 friends. So I'm gonna say this is 14. And then it says if each friend gets the same number of quarters, how many quarters will each friend get and how many quarters are left over? It mentions here that you have 4 friends. So 4 friends, and we're trying to find how many quarters they each get, or how many quarters per friend. So if you struggle with deciding between whether a story problem is equal grouping or a sharing partition problem, one way you can tell is every single time on your grouping problem, the number of groups will be unknown, right? On your sharing or partitioning problem, the objects per group is what will be unknown, right? And that will work that way every single time. So if you struggle with this based on the picture or some other criteria, you can always use where is my question mark, right? Where is my question mark in my equation? And that'll tell you which one it is. So if the question mark is first, then that means it's equal grouping. If the question mark is second, that means it's sharing. And then you can also tell from the picture. So if you prefer to do it that way, you can do that as well. So the picture, I would start the same way as if this were equal grouping. I would start by drawing, in this case, 14 objects or 14 quarters. And then do I know how to make these into groups, right? So if I had 14 quarters in front of me, do I know, how many to put in a group to give to a friend? And without finding the answer some other way, right? I don't know that, right? So if I'm using the picture, or if I were actually using quarters to do this, I don't know how many each one will get. So that's another way that I can tell is like, I don't know how many to circle, right? I don't know how many of these quarters to put in a group because I don't know the answer yet, right? So that's another way that you could tell. If you're able to put your objects into groups, that's a grouping problem. If you don't know yet how many go in each group, that's a partitioning problem. So if you think about this, what would I do if I actually had, my 4 friends sitting in front of me and I've got these 14 quarters and they're waiting for these quarters to be distributed? I would probably just start distributing them one at a time. So I'm going to go ahead and kind of draw my 4 friends here, which you could just do like a stick figure or a smiley face or something. But I'm going to show like the four people that I'm giving these quarters to. So here's my 4 friends, and then I'm just going to start giving them quarters one at a time. So typically what I would do then is draw arrows when I have to do this with the drawing, but if I actually had quarters, I could actually just hand them out, right? So it doesn't matter. I'm just going to like let's just start by giving a quarter to each friend, right? So you get one, you get one, you get one, you get one, right? So everybody has one. Do I have enough to give everybody another one? I do. So let me do that. So you get one, you get another one, you get another one, and you get another one. So then uncircled, do I have enough quarters to give everybody another quarter? I do. So let me give everybody a third quarter. So now you have 3, you have 3, you have 3, and you have 3. So then look again at my quarters that are uncircled, and do I have enough to give everybody another? I actually don't, right? So I'm seeing only 1, 2 quarters left, and that's not enough to give everybody another quarter. So here I could say that I'm solving this equation, 4 times what equals 14. The way I would solve that is to do 14 divided by 4. So it's the same equivalent division equation as we saw up here, right? So my answer is the same. It's 3 remainder 2. However, this time, since this is a story problem, what would my units be? I would say that each friend gets 3 quarters. So the units on my quotient are quarters. And then the remainder of 2, I could say there are 2. So 2 what? That's also quarters. So there's 2 quarters left. So again, the answer was 3 remainder 2. So the setup equation is different, the picture is different, but technically the division that we did in both of these is exactly the same. And the answer is technically the same, although what's different, right? So what we talked about, one way you can tell equal grouping versus partitioning is where the question mark is, right? Because the question mark will always be first in equal grouping. It'll always be second in partitioning. Another way you can tell the difference is, are you able to, when you draw your picture, are you able to know how many go in each group? And we were with the brownies, we were not with the quarters, right? We didn't know how many quarters to put in a group or with each friend until we distributed them all out, right? So that's another way to tell. And then the last way to tell is, are the units the same? Are the units the same on your remainder versus on your answer? So the answer is the same, 3 remainder 2. But with grouping, notice that the units were different. We had 3 packages, but the remainder was 2 brownies, versus on sharing partitioning, they both have the same units. So 3 quarters and then 2 quarters left over. The units were the same.